Hello guys, my name is Arun and welcome to my channel. Welcome to another video of Python hacks. In these video series, you will see some interesting features of Python which I haven't discussed in one of my tutorials, and that also comes in handy when you are using Python and several languages together. Okay, in today's video, I'm going to explain to you guys an interesting concept called as cbindings and how to use cbindings to merge Fortran files and run them inside Python. Okay, before I go to cbindings, I like to show you guys a web page which I found on the internet, which kind of explains the cbindings in much more detail. Now, if we just go to documents docs.python.org. In that there are a lot of stuff, and one of them is called as extending Python with C or C++. Now, long story short about this article is that it just tells what it tells is that um, Python has a few extension modules which can be used to extend certain programs it is used for extending the Python's accessibility to other programs. For instance, there are some extension modules in Python which can be used to access C files or C++ files, and those are called as C bindings. Now, using those C bindings, it is also possible to include other files if other files such as Fortran, provided you use the C bindings which are relevant to those Fortran files. Okay, now let me make it simple. Using C bindings, it is possible to access C files in Python with a little bit of modification. Now, what I'm going to do today is that I'm going to use C bindings which are available in Python as well as in Fortran. I'm going to use the C bindings in both of these programs together in such a manner that I may, using them, I'll be in a position to access the Fortran files in my Python file and do some operations with that. It may look a little confusing, but don't worry, just follow up with me. If you look at my video, you'll understand. I mean, if you just look at my example and everything, you'll understand what's going on crystal clear. Okay, now let's go to the files. Now I have like three files with me. One is a Python file, one is a shell file, another one is the Fortran file. Let me open all the three here. Okay, now let's go to the Python file first. Now, okay, before I go to the Python file, I just open the max. I mean this file as well. Okay, now what I've done here is as follows. I'm going to do two operations today. One, I'm going to do a simple matrix multiplication, a classical matrix multiplication problem, and second is a very extremely simple matrix addition problem. Simple as that. Nothing more, nothing less, nothing complicated. Just two simple programs, and I'm going to do that. And the algorithm for all of that is actually written in Fortran. Now I'm going to use Python, but I'm just going to use C bindings to access those files and run them here. Now let's see how it's done. Now the Python file looks like this. From the first line, in first line, to include the extensions of C inside Python, you need this module called as C types. Now from that C types module, import the following values like cdll, pointer, c underscore int, and c underscore float. And by the way, I'd just like to inform you, like, this concept is entirely new to me as well. I was just trying to look at some options and processes that are available to run Fortran files in Python. I came across this interesting question in Stack Exchange. I kind of looked at one of the examples given by one of the by one of the person who gave the one of the best answers. I was looking through that. I found one of his example. I kind of went through like how did he work, how he or she did the entire thing, and I looked at it was really cool. And so I kind of adopted that example over here and made some modifications and expanded on that. So strictly speaking, this is not my program. I mean, it kind of inspired from his or her answer, but it's not my program. It's not my own inspiration program kind of a thing. So if I make any mistakes in my explanation, do let me know. I'll correct it. No, but just letting you know. Okay. I mean, I thought I'd better say it because otherwise I feel a little guilty if I just copy somebody's hard work and just put it just like that without giving any courtesy. That's it, and sentimental point of view or the inspiration point of view. Thanks to the person. Okay, coming back. Here's the thing. We include C types, CDLL, pointer, C underscore int, and C underscore float. We'll use them in some time. I include a NumPy module for defining the arrays, and I use input time module for calculating how much time elapsed and everything. And then I'm including the shared object file that you get we have to generate from the Fortran file using this command cdll, and I'm assigning this cdll thing to be the cdll option of this file execution to be passed to this file, to this object fort underscore mod. Okay, you can give any name, it doesn't matter, you just make sure that you understand what's going on. This will be actually like our module name, simple as that will be actually our module name, so nothing to worry about it. Now what I've done here is that I just defined the data argument types of two functions that are inside this fort underscore mod, which is essentially mat ops1. Okay, one of them is matmul1, as the name suggests, it's going to be matrix multiplication. And second one is mat add 1, which as the name suggests, matrix addition. What I'm doing is that in this module, in this subroutine, okay, I'm calling all the arguments, okay, and I'm setting all the arguments to be pointers based on how they are accessed in the file. Now to understand this, we just have to look at the Fortran file for clarity. Now let's go to the Fortran file here. Now in this Fortran file, I have two subroutines. First subroutine is called as matmul1 with three variables a, b, and c, and three integer arrays a, b, and c. Sorry, not integer arrays. Real value two-dimensional array a, b, and c, and the sizes defined by three integers m1, n1, m2, and n2. Okay. Now what I've done is that I've included the I'll explain this part a little later. I've included all the 6 variables, and there is this ISO C binding in Fortran, which can be used to invoke C procedures into it, or use that can be used to make Fortran files accessible in C with a little bit of adjustments. You can use ISO C bindings. I've included that module, and in that I'm including C float and C integers. Now what I've done is that I've included m1 and I'm just getting the values of m1, n1, m2, and n2 using C int. Instead of the normal classical integer, I'm using the C int integer that we get using the ISO bindings to define the data type, and with using these values I define the data types and the sizes of these variables a, b, and c using the intent and real options over here. Simple enough. By the way, if you guys want to understand what's happening here, you should know a little bit of Fortran, and you also should know some basic understanding of Python. If you're weak in any of these two or both, then you find it hard to understand what's going on. So if you don't know what I'm talking about, just go back to my video series, watch one of those videos, you'll understand what's going on. If you understand what's going on, then good for you. You'll find this easy. Next, I have introduced 3 integers, and I initialize C to 0, and then this is my matrix multiplication algorithm. Now what I've done is that after doing all this, I've set this. I wrote this command over here: bind C comma name equals matmul1. Now what does this mean? I'm just saying that this subroutine will be binded using C program like contents, okay, with the name matmul1. That's what I'm going to say with this command over here. Okay. So similarly, after this, I have another subroutine called as matadd1, which takes three arrays a, b, and c, whose sizes are defined by nr and nc. Nr is actually the number of rows, nc is number of columns. Fairly straightforward. And then using ISO bindings again, and here I'm just getting all the values, and I'm just adding these two. Simple as that. Like Fortran supports vectorial addition, vectorial or multi-dimensional array kind of addition, so I'm using this. Otherwise you have to use the double for loop like this, and just you have to use a double for loop like this, and then say c of I comma j equals a of I comma j plus b of I comma j, like that. You have to use double do loop like that. Other than that, it's perfectly fine. Just work with this, and just like the top, I'm just binding this program using c bindings with the name, sorry, binding this subroutine with c bindings with the name mat add 1. Now with that being done, we're all okay. Now let's go back to the Fortran file. I mean Python file. Now the thing to keep in mind is that look at the operator list. There are like 6 operators for matmul1, and there are like 5 operators for mat add 1. So if I were to go to the C bindings, if you see, I'm just defining the argument types of matmul1 in the module fort underscore mod to be pointers, for all of them to be pointers. I'm setting the point data types of each one of them to be C float or C in based on the values. Like for instance, arrays A, B, and C here in this matmul or subroutine and in this matat subroutine, all the three are like floats. So I'm setting them to be C floats. I'm setting the other values as integers. So these are C integers. Setting them as pointers of type C integers, like that. Similarly, I set the 5 arguments of matat to be accordingly. That's the only thing you have to keep in mind. Okay, and after that is just a simple routine program where I just define 3 variables and set them to some arbitrary sizes, and then I define 4 matrices A, B, and C and D based on the sizes defined on the top, and I just allocate them. The thing is, the data type, I'm using the data type to be C float, which I just imported on the top instead of the regular NumPy data type floats. NumPy data types, I'm using the C float C binding data types over here to tell the compiler explicitly, Python compiler explicitly, that I'm using C binding stuff. And then I'm just generating random values for A and B, and then this is actually the Fortran call. Now the Fortran call is simple. This line and this line are just for clocking the how much time it took place for both the operations to finish. Now this one, this command time in the module time, just when it's clocked in, it just displays that time has elapsed from a certain reference point in the past till the present condition. Okay, and that's when the start happens. When this line executes, the same command is executed over here. It's going to pass a number of seconds. It elapsed when some reference point in the past till the current situation. Now between these two clocking intervals, there would have been some time that would have taken for this entire operations to take place. So if we just take stop minus start, you'll get in seconds how much time it took for these two operations to take place. That's the logic behind it. Now once these two are done, okay, this is how the function calling happens. What I'm going to do, I'm just going to write module name and then the function name, and inside I'm going to pass the variables A, B, C and the integers as well, but with a little correction. I'm going to pass A, B and C as C types, and the data of these C types as pointers, and with C underscore floats. A, B and C are arrays, so those values are passed as C types, and with the data being pointers of C floats. On the other hand, M1, N1, M2 and N2 are actually integer values. They are not arrays, they're just single scalar values. So I'm just passing them as C underscore C integers. Simple as that. Like that, the same procedure adopted. I'm passing C twice. Okay, as 2 arguments, and D as the third argument, for where the answer of C will be addition of C twice will be stored. And then I'm passing the sizes M1 and N1 and N2 to define these sizes, and that's it. Simple as that. And now this line will print like Fortran took so many microseconds for the option, like that. And now here I'm going to use the NumPy module for matrix multiplication using np dot do the same, and these things are exactly same as at the top. For the addition, I'm just doing a simple arithmetic addition using Python, simple as that. And now this part is done. Like we just looked at the Fortran file, we understood, we had explained you guys what's happening. I looked at the Python file, I understood that's what's happening, and everything works fine. But thing is, only thing that's kind of lagging is this line. Like how do we generate this shared object file first? And for that, let's look at the shell file. Now, if to generate the shared object file, what you need is that you just have to compile and build a shared object from the file object, not the mat file. It's actually mat ops mat ops file. Okay, you just have to generate a shared object file from this file using this entire length of compiler flags. There are like so many compiler flags over here. Like I'll just explain some of them because many of them I have no idea what they do in full detail. Minus O3 stands for third level of optimization, so that will optimize your code speed wise and memory wise. I mean, it'll optimize your machine code speed wise and memory wise to the maximum possible extent using this compiler flag, and all the other compiler flags are used for some extra accessory stuff but it's kind of necessary. And then shared flag is actually used for making a shared object that can be accessed by other programs in proper manner. Okay, and then matops1.so is actually the module name, which I'm with the shared object file name that we're going to get, and then this is the file name. Once you execute this entire stuff with this line, then your shared object file will be made. So let's go to terminal, and then let me clear this up. Okay, let me just raise the screen a bit. Yeah, now what you have to do is you just have to copy this entire stuff and paste it and press enter. There you go. Now if you press ls, you'll get this file matops1.so. now what you have to do is that you just run your Python file just like that. For instance, if you look at my system, if I Python, I have like 3.5.0 Python. That's my default Python from Anaconda. Now that's what I've done. So if I just type Python and then the file name cbindings.py, press enter, it just says that Fortran took like 89 something microseconds, whereas NumPy took like 667 something microseconds. So to run this again, just type the up command, and you get like Fortran took 187, NumPy took 192, blah blah blah, and there you have it. And some other time you get like Fortran took 91 microseconds and NumPy took 70 microseconds. Now here's the thing. NumPy is actually a module for Python made using Fortran or C under the hood. As a consequence, all the modules all the functions in NumPy and are super optimized to start with. So if you were to build a Fortran file from the scratch, and that will mimic the exact operation that is done in NumPy, it may be slightly slower, because some of the we had to take a lot of optimizations for that. But Python files are heavily tested, so that's the reason. As a consequence, what happens is that you may not get a proper speed up when compared to when you're using pure Fortran files here or pure C files here. But don't worry about it, it's not your problem, it's just some of the compilation issues. You can make one, you just have to use a lot of compilation flags and super optimize the code to get that, so it's not a problem. But this method will be really helpful in some of these situations like these. Like if you want to build up your own function which has to be super fast or something, which kind of uses several NumPy functions and on top of it, then it will not work. It will be slow. In those kind of cases, building a function right from the scratch using Fortran or C will be beneficial. So as a consequence, here for NumPy might be slower when NumPy might be faster than Fortran, but if you do a really complicated program, then NumPy will Fortran files will be much faster than NumPy. So don't worry about it. So yeah, don't worry about it. And if you guys want to run Python 2, you can do you don't have to compile this again. Just Python 2 will be sufficient. Just type Python 2 and then type your file name. And that's it. Press enter and that's it. It just says that Fortran took 96 seconds, microseconds, whereas NumPy took 174 microseconds. So you can run this again. So like that, so on and so forth. It's not a big deal. Not a big deal. That's the way it works. Now, here's the thing. In my system, what I have is that I have both Python 2 as well as Python 3 installed. So I have to run to execute files to make Python 3 is the default Python in my system. To make the Anaconda version of Python 2, which I've installed as the default version for some time, I have to use this command source activate py27env. That py27env is actually the environment name I've given for my Python 2.7 series. So if you're running a system, it doesn't. If you don't have to run this. So just saying that this is for my system only. So when you're running your work, you can remove this line. It'll remove this line. This is not necessary. For my system it is, but for your systems it's not necessary. That's the thing. So other than that, if you look at it, this is plainly easy. Okay. Now here's the thing. In my last video, I told you guys that you can with F2Py you can do the same thing. There are pros and cons. The pros of the cbindings is that your Fortran code has to be compiled only once. For any version of Python, like Python 3, it doesn't matter whether you're running Python 3 or Python 2, you just have to compile your Fortran code only once with cbindings. And you have to see here clearly, I just compiled this Fortran file only once, and it works both in Python 3 as well as Python 2. I do not have to recompile it. That's the advantage. Whereas if you were to do this in F2Py, what happens is that you have to compile the file separately for Python 3, and if you want to switch it to Python 2, you have to recompile the file. If you just reuse the file just like that, it won't work. Sometimes it might, I'm not sure, but mostly it will throw an error based on my intuition. So if I'm wrong, correct me, and correct me. That will be useful for others as well. If you guys experiment, just let me know. I'll keep that in mind. Okay, that's the thing. Now here's the disadvantage of cbindings. The moment you take cbindings into picture, as you see from this Python file over here, this line is okay. But after this, you have to define the argument type again for each and every function and subroutine that you define in your Fortran file. You just have to define them separate again. You have to just define the argument types every line. Third thing is that's the first thing. You just have to define the argument types. This line is not a big deal. It's simple. But the second major issue is you just have to follow the data types like cint and cfloat everywhere for the data types of these variables. While defining them, you have to define them like that and define them like that. And when you pass them into variables, when you pass those variables, you have to make a lot of changes. Like you just have to pass them as data type, as pointers, as c_float, and you have to pass them as in the cint as well again. Like sometimes you may not have to pass them, you can just directly put the values, I guess. I think that might work, but if I'm wrong, this is just based on my understanding. So if I'm wrong, let me know. But as far as my understanding goes, but you have to do a lot of stuff like this. But even then, even if you don't do this, the major disadvantage, and even if you can tolerate this, it's not a problem. But the major disadvantage is this one. You have to define the argument types in the beginning like this. Otherwise, it will just this has to be done for each and every subroutine. Like if you have I just have two subroutines here, so I was like, okay, this is not a big deal. It'll take me hardly a minute or two to define, so it's okay. Imagine a case where you have like 100 or 200 subroutines here, or several hundred functions over here. It's quite not possible to define the argument types every now and then, every time. On the other hand, with F2Py, you don't have to do this. Your code will be absolutely Pythonic, and your Fortran code will be absolutely Fortran like, and all you have to do is just a simple correction. No, you don't even have to do any correction. You can just import it just like how you import a Python routine, and that's it. Okay, so that way, that's one of the advantage you have in for F2 that is not available in cbindings. So that's about it. Now, if you guys notice, these are some of the advantages and disadvantages. You guys can use both the methods, but pick the one that is kind of really helpful and advantageous to you guys. Okay, both of them are really nice methods, so it just depends on which one you guys want. And I'm not sure by which. I mean, I cannot say with absolute surety like which is superior or inferior. I can't say with it. I find both of them okay. So if you guys found out something like which one is superior, which one is inferior, with some proper reasons and justifications, so put those links on the comment section. I'll definitely go through that, and it will be helpful for others as well. With that, I'm concluding this tutorial. Thank you guys for watching, and next tutorial I'll just come up with some interesting topic. Until then, see you guys and take care.